In this video, we're going to graph the curve y equals 1 over x squared minus 7x plus 12 and determine some other information. Well, the first thing we want to do is graph the curve y equals x squared minus 7x plus 12. So it's good to see if we have any x-intercepts, and in this case we do. We have an x-intercept at 3 and at 4. Our axis of symmetry is therefore going to be halfway in between 3 and 4. 3 plus 4 over 2 is equal to 7 halves. Now to determine the y value of the vertex, we can evaluate 7 halves minus 3 times 7 halves minus 4. We end up with 1 half times negative 1 half, which is negative 1/4. And so we have a vertex at 7 halves comma negative 1/4 and x-intercepts at 3 and at 4. And so this is what our curve will look like. Okay, so now the first thing we do when we go to graph it after we sketch the parabola itself is draw a vertical asymptote at each x-intercept, and we've done that. We then go to each point where there's a y-coordinate of 1 or negative 1. So we've got a couple y-coordinates of 1 there. We don't have any y-coordinates of 1 underneath the x-axis, although there is some of the parabola is underneath the x-axis. What we can do is actually say to ourselves, the curve y equals x squared minus 7x plus 12 has a minimum at the point 7 halves comma negative 1/4. Well, that means that the curve 1 over x squared minus 7x plus 1 half will obviously have an inverse relationship with x squared minus 7x plus 12. In other words, when x squared minus 7x plus 12 is big, 1 over x squared minus 7x plus 12 will be small, and vice versa. So if x squared minus 7x plus 12 has a minimum, 1 over x squared minus 7x plus 12 is going to have a maximum. The x value will stay the same, but the y value will be 1 over negative 1/4. Now, 1 over negative 1/4 is the same as 1 times negative 4 over 1, which is negative 4. So what we're saying is that there's a maximum at the point 7 halves comma negative 4. Well, that point is way down here on the graph. And it's a maximum, so we have to remember to draw down from there. So the upper left portion is something that we've seen a few times before, and the upper right portion is something that we've seen a few times before as the x values, as the blue curve goes down, the red curve goes up, and vice versa, while respecting the asymptotes. Now, in between, in this middle portion down below, we see that from that vertex, the blue curve goes up in each direction. So from the point 7 halves negative 4, our curve needs to go down in each direction, while at the same time still respecting the role of the asymptotes. And so we draw something that looks like this. Now we're going to state our domain and range. Our domain is the set of all x element of the reals such that x cannot equal 3 or 4. Our range will be the set of all y element of the reals such that y is less than or equal to negative 4. That's this portion down here. Or y is greater than 0, and that's this portion up here. But notice y can't be anywhere in between 0 and negative 4. Our increasing intervals will be as long as x is anywhere in the interval from negative infinity to 3, which is this top part, or anywhere in the interval from 3 to 7 halves. Now we can put a round bracket on the 7 halves because your textbook accepts that, but personally I think there should be a square bracket on there because I think, based on the definition, of increasing and decreasing intervals, that the 7/2 is actually part of the increasing interval. And similarly, I think it's actually part of the decreasing interval, although your textbook seems to think otherwise. So we can say our decreasing interval is everything from 7/2 to 4. That's the right part of the bottom portion of the curve, in union with everything from 4 to infinity. And like I've been saying, I think it's more appropriate to include the 7/2 in the decreasing interval as well. Now, our positive interval is going to be any x value from negative infinity to 3, in union with any x value between 4 and infinity. Our negative interval is going to be any x value between 3 and 4. Our horizontal asymptote is at y equals 0, and our vertical asymptotes are at x equals 3 and x equals 4.